Prashant is currently working as a faculty in the Department of Electrical Engineering and Computer Science, IIT Bhilai. He has received his PhD from University of Manitoba, Canada, MS from University of North Dakota, USA, and received Bachelor's of Engineering degree from Rajiv Gandhi Pratyogiki Vishwavidyalaya, Bhopal. His major area of interest include application of power electronics in power system and renewables, microgrid dynamics and control, machine learning and AI application in power system. He has enlisted as Canada's top 150 scientific innovators and groundbreaking researchers by MITAX in 2017. Now, on behalf of Power and Energy Group NIT Calicut, I may request Professor Prashant sir to carry over the session. Over to you, sir.
So over to you, sir.
Yes, just 1 minute. I am just taking out my slides. Just give me 1 minute. Can you see my screen?
Yes, sir. Yes, sir. Yes, sir.
Just so thank you very much, guys. So I would like to thank NIT Calicut for giving me this opportunity to present my work. Essentially, in this, I think I'm going to give 2 sessions in this workshop. So, in this one particular session, what I'm going to talk about is the basics of the machine learning techniques. And when we talk about the machine learning techniques, I think the most primary ones when you hear about is the clustering method. So I will talk a bit about the clustering methods. So of course there will be first introduction to the machine learning. So we'll try to set up the dais for the introduction. Then we will talk about the clustering methods. And then if possible, we'll look at some of the examples. Now examples, I mean, with respect to the clustering methods itself, if the time permits, we will look into the example. Otherwise, in the next session, which I'm going to do, I will carry forward this particular presentation to that one. I think that presentation is also tomorrow. So those clustering methods example I will show maybe tomorrow, and then tomorrow I am also planning to show some of the results from the AI applications of my research scholars that they have done. So if you look into the machine learning and the machine learning technique as such, then what essentially it does is that it's a very common thing to understand that it is the field of study that gives the computers the ability to learn without being explicitly programmed. Okay, so what we are essentially doing is we are just starting up the machine learning algorithms with some nodal points, and then from there onwards, based on their experience, we allow the machine itself to upgrade their ability to predict the things. Okay, and it is not true that machine learning is something which is a very recent technique or so. In fact, if you look into the IEEE, so if a simple search if you do on IEEE, then you will come to know that there are papers as long as back to 1960s. So it's not a new method. Okay. In fact, for one of my research scholars, I was doing a literature survey, and then generally what happens in literature survey is that the better idea is that you start from the very beginning and then you go into the you start with the 1960s, 70s, try to see if that problem has been solved or attempted to be solved earlier. Then you go further in the Middle Ages with the involvement of softwares, how the problem solving has been improved, and then in the recent ones you try to see the more state of the art problems which are prevalent. So when I was looking into some of the machine learning applications in the power system, actually fault analysis and all is something which has been actually attempted by people back in 1960s also, and that was using artificial intelligence. So it's not a new thing at all. The reason why it has suddenly picked up, and you will see a lot of institutions now providing a huge amount of trainings available in machine learning applications and artificial intelligence, deep learning and all. The reason is that now we have, first of all, we have a lot of data now, because the technology has recently evolved in the area of sensors. Okay, so if you look into from the power system perspective itself, if you look into the sensors now, you have this PMUs, you have of course SCADA is there, then you have a lot of smart meters are there. So you can see now that with the evolvement, and this is not something which is new. Okay, this is not something which is old. So PMU, SCADA has been prevalently there for a long time, but mainly smart meters and wide area measurement based techniques, they're fairly new. So as a result of which you can see that you now have a lot of data which is available to you. And as a result of which you can see that since you have a lot of this data available, there is a industrial also involvement which is allowing the data to be either recorded or either to be produced. And this can help the researchers to develop the algorithms. Okay, because data you might have heard, the participants might have heard a lot of time that many industrialists nowadays they say data is the new oil, because it is the fundamental basic block for any machine learning techniques. Okay, then so this is one of the reason why it has recently picked up. There is one more point which is actually I missed, but I would like to mention here, is that computational capability. So computational capability is something which also recently you can see with the processors having a lot of development in their technology. You can see a large amount of data can be processed within a short duration of time. And as you're collecting more and more data, the idea is also the same thing, that if you have more and more data, how we can make use of that thing. You need to have computational capability to make something good out of that. But fortunately, I mean, previously we did not have that kind of capability, but now we have it. With GPUs and high performance computing, and not even high performance computing, you can see that if some of you might have done some training in the deep learning and all, with a simple i3 even kind of a processor, you can do some deep learning kind of programming. So you have that computational capability packed inside a very small chip, which was not possible before. You might have needed a room full of stacks of processors to just process a small bit of information. Okay, so even that has been significantly improved, as a result of which you are seeing a major thrust in this possibility of using machine learning for various applications. Now, you might have heard about supervised, unsupervised learning, semi-supervised learning, reinforcement learning. So supervised learning, if you just want to go through it, maybe we'll start with the unsupervised learning. So unsupervised learning is essentially what we say is that in this learning, the data set does not have a labeled output. Okay, so you might be having a bunch of data points, okay, but we don't know that in which class or which category they depend on, or they are marked out. Okay, so the outputs are not labeled. So the mainly help that we get is to have some sort of a natural structure. It can help to identify within the set of the data points. Okay, and it is visible. Is this visible to you? Hello.
Yes, sir, it is visible.
I am just getting a call from your end. Okay, anyways. So essentially, what you can see is that they're mostly used for exploratory analysis and dimensionality reduction. I will talk about that in a minute. But essentially, if you see that how it can be used, and this is a very common thing which if you might have seen the courses in deep learning and all, they give this very many of the textbooks and many of the reference material, they give this kind of a example. For example, if you're going into the mall and then there is a and then let's say you're going into a shop like Reliance Trends, okay, and they just want to see what category of the age group is visiting their section. So for example, if they have just introduced some video sensors or some sensors which are just tracking the possibility of finding out that how many people are visiting their sections. So for example, there could be an area which is women's section, there could be area um, which is kids section, and there could be area which is male section. So you can see somehow that people are coming here. Now they may not have previously made a cluster out of it, but once they see that people are appearing in this section, they can maybe make a cluster later on, saying that the people when they enter, they go into one specific region and they try to be there for a longer duration. Similarly, there could be some people going in one other particular section and then spending time over there. So in those bases, you can try to identify that this could be the women's cluster, this could be the kids cluster, this could be the men's cluster. Okay, so that is essentially unsupervised learning. We can take a n number of examples like this, but just to give you an exploratory kind of description. Okay. Then the second thing, and dimensional reduction is something I will talk about a bit later with respect to the unsupervised learning. But then we have second thing which is called as supervised learning. So supervised learning, as the name suggests, you can say that the ground truth labels are essentially available. Okay, so when you are trying to look into the various data sets, in this case itself, when a person is entering, they may just give an information that it is a woman who is visiting our store. So there is a very high possibility that she might go into the women section. So that is a supervised kind of a learning. So truth labels are already available to you. And then what happens is that it tries to learn a function that gives a sample of data and desired outputs, and then try to best approximate the relationship between the input and the output. In fact, in the supervised learning also, it can be categorized into regression problems and classification problems. Regression problem आप लोगों ने सुना होगा कि for example, if you're predicting the house prices could be a function of how old the house is, what are the number of bedrooms it has, in which locality it is available. So these are the different parameters. So it's a multi-dimensional parameter, and based on that, you can identify the price of the house. So you can actually design some sort of a algorithm which tries to fit in with all these different variables and try to come up with a new function in itself, where the price of the house. So if you're just talking about the house price, it is a function of the number of bedrooms. It can be number of bedrooms, it can be the locality. So your locality, you can just classify it as some binary number, and then based on that, it can identify. So number of bedrooms, locality, and age of the house. Let's say just three parameters. So house price can be can give function of all these things. So what you are doing essentially is you are trying to provide some data as the input. Generally what you do is whatever data is there, whatever data it comes to you, you just split that data into 70-30%. 70% you can use for the training purposes, 30% you can use for the test purposes, validation purposes. Okay, so with this kind of problems, they're coming into the category of regression. So once with the 70% of data, what essentially your machine learning technique is doing is it's determining this function. Okay, and then the values of this function can also be seen in the programming, that what kind of function it is determined, and later on, once the function is determined, you can just provide the number of bedrooms, locality, age, and then it will just give you the housing price. So that's a regression problem. Then we have a classification problem. Classification problem, if you look from the general perspective, of course, I will come to power system examples in a minute. But for example, okay, maybe let me give you a classification problem itself in the power system. So classification problem, for example, if there is a fault in the system, and you're observing some of the waveforms. So it is some waveforms are going like this. Okay, and let's say this is a voltage waveform you're obtaining at a particular bus or so. What you may want to identify is that what kind of class of fault it is. Okay, what I mean by class of the fault is whether it's a symmetrical fault or whether it's a symmetrical fault. Okay, now a person with a very very seasoned person with a lot of conceptual information, they would say that, okay, just by looking at the graph, maybe one can identify it. Yes, it is possible. But nowadays, what happens is that the system size are becoming huge. So it may not be possible to put sensors at all different places. So what essentially you may also have to do is with the limited number of sensors information also, you may have to predict the things at some other location where the sensors are not available. So that state estimation kind of problems are also there, which can be solved by using ATAL techniques. Okay. So this is a simple example of classification problem in ML techniques. So if a waveform is given to you, you have to identify by A to ground fault hai, B to ground fault hai, which phase is involved, or if multiple phases are involved, then which are these. Okay. Another kind of problem, classification, not essentially classification, but in the regression kind of thing, we can try to identify that if the waveform is appearing, then we can just try to identify that where the fault is. So there is one is classification, another one is location problem. Okay, so fault classification. Okay, and then you can also look into the location problem. So one of my student actually has worked into this. So if today the time does not permit, I will show you the results definitely tomorrow from our thesis. Okay, so that's essentially the regression classification problem. Now this is not new. You might have come across this this particular definition at some point of time. The idea is that what is the learning? So learning is, and that's not my definition, of course. You can see this at various references. Learning can be defined as improving on the task T with respect to the performance, which is measured, performance measure P, and which is based on some experience E. Okay, so there is some task, we are doing some performance. There is a way to measure our performance. Okay, how good we are doing or how bad we are doing, and based on how good or how bad we are doing in our performance to perform a task T, we gain some experience. Okay, now I would like to give some examples. For example, if there is a simple handwriting recognition kind of a problem. Handwriting recognition. Okay, If I just take this simple kind of a example, then what could be the task? What could be the task? The task could be recognizing the handwritten words. Okay. आप लोग में से अगर किसी ने ये चीजें कभी प्रोग्रामिंग अगर आपने की होगी मशीन लर्निंग या डीप लर्निंग में, तो आप देखेंगे कि कई तरीके से इस चीज को हम सॉल्व कर सकते हैं. देयर आर SVM methods and all available by which you can do this kind of things. Okay, logistic regression and all. So there is a recognizing the handwritten words is our task. What could be the P? What could be the P here? The P could be the percentage of the word, the percentage of the words correctly classified. Now, just try to see here that we are going for supervised learning. We are not going for unsupervised learning here. So we can see that the performance measure could be जितने आपको handwritten words दिए थे उसमें से आपने कितने सही ढंग से पहचाने. That is a performance measure. Okay, and then essentially what you can do is with your experience E, you can say that you can just try to improve your ability to predict those kind of things. Okay, so your E can be simply the database of human labeled images. So now this database is something which you have correctly predicted. So you're getting a lot of experiences now. So your database is kind of increasing, okay, of handwritten words. Okay, is there a mechanism to get here in this talk feedback from the audience? Can they reply to me over chat?
Yes, sir. They can reply to you on chat.
Okay, so if I'm asking some question or so, they can always reply back. Right?
Yes, sir.
Okay, so if that is the case, I would like to know from the audience. I will just try to give them another maybe scenario here, and then based on that scenario they can respond over chat. Okay, chat पे respond कीजिए, बोलिए मत, नहीं तो otherwise there will be a lot of people starting to talk. Okay, so you might have heard about the spam email detection. Spam email detection. So from spam email detection, what do you think should be the task? Can you respond over chat? Anyone? I just want to see also. Yes, that's correct. That's correct. So whether it's a legitimate or it's a spam email. Perfect. Perfect. What should be the performance?
Once the participants responded, remove the mails for particular mail IDs.
Yes, exactly. So percentage of emails that are classified correctly. And then with the experience, you will see that the database can just keep on increasing. Okay. So as you are trying to work on this thing more and more, you will see that the task, and as the performance measure is increasing, you will be able to expand your database essentially. That is much more able to classify whether a given email is spam or not. Okay. By the way, if you does anyone of you have any idea that how you actually do this particular part? This part, how do you classify? How do you classify? Has anybody worked before on spam email detection? How do you generally classify if an email is a spam email or not? Anyone? Okay, so generally what you do is spam emails, you will see that there will be, yes, so somebody just said there are particular words, that's correct. So आप देखेंगे कि emails जो आते हैं आपको, spam emails आते हैं, उसमें कुछ ऐसे होते हैं words like price, money, respond, urgently, okay, account, OTP, things like this. So you will see that there are a lot of these kind of words which will come. So generally what happens is that your whatever spam email detection, this method, it actually tries to read your email word by word. Okay. And then what essentially happens is that it already has this database of the words which can appear and which have sort of been classified as the words which may appear in the spam email. So it just tries to see that whether these kind of words are there or not, and then based on that it tries to rank your email whether it is having a lot of words like this, or it tries to raise a flag that yes, these words are there in this email, so there is a very high probability that the email could be a spam email. Okay, and as you go on further and further, you will see that this database will just try to update itself, and then you will see suddenly that you have a spam email detection which is having a very good accuracy. Okay. अच्छा, इसके लिए अभी मैंने कुछ समय पहले आपको एक और चीज बताई थी which is called as data division. Okay, so data, we just said that it is 70% or 30%. So this is used for training. This is used for testing. So whatever it is, like for example, if you have 100 data points, 70% we will use for training and 30% we will use for testing. Why we are doing it like that? Why don't we use entirely 100% data for the training itself and then just try to see the new data which is coming up? We'll just take that data for our testing purposes. So why we are splitting this kind of thing? Does anyone have any idea? Validation of the model, that's correct. See, it is essentially like yes, validation, so that's correct. So what essentially I'm telling you is that when you're doing, if you're not doing the splitting of the data, okay, then the idea is that, for example, if you're doing some sort of a power system course, let's say, and then in the power system course, let's just pick a topic. Let's just say that we are doing a study of the long, medium, and short transmission lines. And I have given you some theory, and then in this theory we have done some numericals, and let's say I'm doing some 10 numericals. Okay. And then if I say that, okay, I am giving you 10 numericals, and let's say they are grade-based numericals, so there will be some concept involved. And then what I'm telling you is that चलिए भाई आप ये 10 गेट की प्रॉब्लम्स कर लीजिए और आप डायरेक्टली गेट का एग्जाम लिखने बैठिए. Then you might see that gate problems, if you're doing, then they involve a lot of concepts, so it involves some thinking. Okay. So any competitive exam, you will see that it involves thinking. But eventually what may happen, आपने कभी इस चीज को, human brain is very interesting. So you may see that concept अगर आपको पहली बार आपने उसको क्रैक किया है सोचते हुए, then you will see that the second time also it will try to think in a particular way. But for example, if some concept I have already told you and some problem I have already solved it for you, okay, then you may not be able to, you may try to think on the similar lines, but the concept may be applicable in some other different way. Okay, I'm not sure if those words are able to suffice the thing what I wanted to tell you. But the idea is that अगर मैं आपको सारी की सारी गेट प्रॉब्लम्स करा दूं सॉल्व करके और फिर आपको बोलूं कि आप गेट में बैठिए, और हो सकता है कि एक कोई प्रॉब्लम आपके पास ऐसी है जिसमें आपको कोई अलग तरीके से उसका रीजनिंग सोचना पड़े और आप शायद न कर पाए. लेकिन अगर मैं ऐसी चीज में आपको ट्रेन करता हूँ कि मैं आपको 7 प्रॉब्लम कर रहा हूँ,
Apologies for the interruption, sir.
yeah.
Sir, actually, a few attendees might not understand Hindi parts of
Oh,
this.
sure. Okay.
Thank you, sir.
So what I'm saying is that that in this particular gate, in this particular examples that I'm doing, for example, if I'm just exposing you to 7 problems first, and then ask you to solve 3 problems which you have not seen, okay, which you have not seen before, then it will be a good judgment that 7 conceptual problems you have solved, but are you able to apply the same concepts to 3 absolutely new problems which you have not seen? Then it's a very good idea to check your learning. Okay, so that is basically why you're doing it. So some of you might be aware about this thing, but we always have to cater our lecture based on the varied audience. So that is the reason why I just wanted to uh, spend some time on the splitting of the data. Okay, and then this is something, data splitting, which you can easily do you can do in Python. There is a method called train test split. By using that, you can split your data. Okay. So now let's just go to the procedures. This is sort of a flow chart, which is there. So what you essentially do is you first have raw data, okay, and then based on this raw data, you're doing some sort of a data selection. So in the huge amount of data that is available to you, there is a possibility that some of the data may not be of any use to you. Okay. For example, in the housing problem itself, there might be some of the data which may not be of any use to you. Okay. So you may want to remove that kind of thing. So data selection is there. Once the data selection is done, then what you do is you do the training and validation. Okay, so training and validation of the data. Okay, and then the next stage which comes is feature selection. Okay, now generally this training and validation of the data and feature extractions, they go sort of hand in hand. Okay, I will talk about that in a minute. And I will talk specifically from the power system point of view. So then you can have feature selection, then you have essentially the features, and then you have the function estimation is there. Okay, and then from the function estimation you can get the output, and then output, of course, what you have to do is you have to do evaluation of that output, whether this output is giving me what kind of percentage evaluation is there, and then that evaluation actually gives me the performance matrix, what we generally call as number of false positives, number of false negatives, or true positive or true negatives, things like that. So it gives you a performance matrix. So we have sort of discussed about these parts so far, training and validation. Now we talk about feature selection. Can you tell me, somebody, that what would be the feature selection features, when I say features, in terms of power system? Okay, and I will request you to maybe don't unmute yourself and say, but rather than type it. Okay, so that way I can. Okay, fine. Okay, for example, some of you are giving me some answers like voltage, current, power. For example, let's say if I'm giving you this kind of a waveform, okay, it's a very rough kind of a discussion we are doing. Of course, there is much more data, intrigue kind of data which is available. So if this waveform is given to you, and let's say 2-3 other waveforms are given to you, 2 other waveforms which are the B and the C vector, I'm also giving to you. So VA, VB, VC. So essentially 3 waveforms I'm giving to you. Okay, and then if I am just asking you that what kind of what kind of fault it is, okay, what kind of fault it is, then can you determine it? whether it's a symmetrical fault or unsymmetrical fault. Can you find it? If I'm essentially giving you 3 waveforms and I ask you to just determine whether it's a symmetrical fault or unsymmetrical fault. You all are aware about symmetrical and unsymmetrical fault, right? Sure. Yes, fine. So symmetrical and unsymmetrical. Essentially the faults after which the 3 phases are still in balance condition, we call them asymmetrical. The 3 phases which are not in balance with each other, then we call them unsymmetrical. With the 3 waveforms given to you, can you identify whether it's a symmetrical or unsymmetrical fault? Well, you may then, what you have to do is you may have to go into some of the conceptual understanding about how you can identify whether it's a symmetrical or unsymmetrical fault. For example, if there is a unsymmetrical fault, then you will see that all the sequence components which are available, they might be in a different when the fault appears, you may see that they may be decoupled in the nature. Okay, first thing. And another thing is, if it's an unsymmetrical fault, and if it's a ground fault, then you will see that the 0 sequence component is available. Okay, so you may see that by looking at the graph itself, if you just try to find out the 0 sequence component of it, and then if you essentially identify that there is a finite amount of 0 sequence current or 0 sequence voltage which you are finding out, then you can just conclude that it looks like an unsymmetrical fault to me. Okay, then later on you can further try to refine your method. Okay, for example, just by looking at the thing, you may have to extract some of the things, extract some of the features out of it, which will first tell you that okay, this data is available to you. Let me just try to extract some another feature. Okay, so Abhi is you can do is from this data itself you can try to identify the 0 sequence component. Okay, and that essentially is your new feature which you're trying to identify from the existing data, and then this may then be able to identify whether it's a symmetrical or not. So this is what we are talking about, the feature selection. Okay, so what feature selection essentially is that whatever the data is given to you, you may have to find out the essential information out of that data, which will be actually able to classify whatever our requirement is in terms of prediction. Okay, now it is not necessary that it has to be 0 sequence only. Can somebody now tell me that what could be other kind of features which could be available? Okay, let me just write down, it could be 0 sequence, one thing. Okay, and then let me just say it could be positive sequence and negative sequence also, just in case, because if the positive, negative and 0 sequence are coming up, then how they are related with each other may then we be able to understand that okay, if they are related with each other in a specific way, then we can say that okay, it looks like maybe a single line to ground fault, or double line to ground fault, or triple line to ground fault, something like that. Okay. Yes, anybody else? So somebody is saying angles. Okay, so maybe if the angular information we might be able to identify. Okay, magnitude, fine, angle and magnitude. Anything else? What about THD? THD can also be some sort of a parameter or feature which can be extracted to actually identify that what kind of harmonics are present, and based on the harmonic information we may be able to infer something else. Are you getting my point? Yeah. So for example, if you are doing some sort of a stability study, and in the stability study you may have to identify that okay, so in the stability studies the system may become unstable if there is a oscillation of around ¼ Hz frequency in the system. Then what you may have to do, you may either have to do the harmonic analysis of that system. Okay, when I say THD, I essentially mean the harmonic analysis itself. So you may have to do the FFT of the entire thing, and then based on the FFT you may be able to identify that okay, you may either do FFT or you may either do Prony analysis depending on your application, the resources you have. So based on that, you may be able to identify that, okay, there may be a quarter hertz or there may not be a quarter hertz frequency which is there. So the system may be classified as stable or unstable. So that could be another thing. So essentially, that's what I'm saying, that once the feature is there, then you come to the next step, which is called as a function estimation. So function estimation is once you have identified the feature, now based on that feature, we are trying to set up a relation based on our input and output. Okay, we are trying to estimate a function which fits that particular. Okay. So that is our function estimation. Once the function estimation is there, you will get output, you will do an evaluation, and then you will do some sort of a performance matrix. So performance matrix is something again that if 45 or 50 data points are given to you and you have been asked to identify whether it's an unsymmetrical fault or symmetrical fault, you first try to extract the feature, you try to identify some sort of estimation. Generally, this thing is something which is not you do, but the method itself does this thing for you. The optimization methods which are available in machine learning. Then you're getting some sort of output, and the output you are doing some evaluation out of it, and then performance metric will tell you whether it's a true positive, true negative, false positive, false negative, and based on that you can find out the accuracy of the system. Okay. So generally, if you see in the deep learning method, they tell you about the accuracy, and even in the machine learning methods, at the end you can try to see the accuracy of your methods. Okay, so so that's essentially how the procedure is. Okay, let me come to the next one. So what are the MI applications in power system, machine learning applications? This actually has to be, sorry, it's not. This is ML applications in power system, and then you have to. I'm just giving a host of some different problems to just identify that what kind of problems that can be solved. So first problem that I'm saying is the preliminary judgment of fault, detecting the type of fault and the possible methods of diagnosis by using stacked autoencoders in combination with deep neural networks. So you may first have to, if you're taking any waveforms, you might have to first divide it into different chunks, and then based on those information that is available to you, you just feed it into your deep learning method, and it's again a supervised kind of a method. So you know that what kind of output is there, and then you can use deep neural network to find the type of the fault, which we have just discussed. Okay, so this is a very common thing where nowadays this ML applications are being used. Okay, then second thing is second application could be, and these are just 3 applications I mentioned, but there are a lot more. So detecting stealthy false injection which cannot be detected by traditional bad data injection using state estimation by making use of support vector machines. Not necessarily support vector machines, there are a lot of other methods also, and this somehow comes in the category of cyber security. Okay, for example, if you have some 3 or 9 machine system, okay, 3 machine system, 3 machine 9 bus system is there, and then suppose some intrusion agency has been able to get hold of one particular smart meters or the data which is available at a particular bus. Okay, so let me just draw it very roughly here. Okay, so generally how you have the 3 machine system is something like this. There are of course transformers here, and then you have system like this. So you have like this, and then there is some loads at this point, there is some load at this point, and let's say some of the intrusion is able to get hold of the meters which are available at this particular bus. So then what they can do, they can essentially try to manipulate the data which is going from here. So they can try to change the values of power, they can change the value of the current, they can change the value of the voltages. And voltages, when I say, they can change both the magnitudes as well as the angle. Okay. So what you may have to do is you may have to identify that whether this particular bus is compromised or not. In that case, what you may do is, first of all, the things may be quite simple. You can simply write the KCL and KVL. Okay, for example, at this particular node, if you write the KCL, then whatever the power is coming here, the same amount of power will be, some power will be going in this direction and some power will be going in this direction. In total, they should add up to 0. If that is not doing, then you can come to a conclusion that there is some problem with these data. Okay, and then you can identify the buses which may be having some issues. So that way you can flag a warning that the data is not coming properly. So some of the buses may have been compromised. So this is a simple way, but there is some other way by using our previous experiences. We can just try to see the pattern of the data which is coming from the different buses, and then we can identify that whether there is a false data injection or not. Okay, so this topic is comes under the cybersecurity applications of machine learning in power system. I'm not going to deep into that. I think we have Dr. Anurag Srivastav later on as a speaker in this particular workshop. So he will be, I think, talking more about that. This is very important nowadays because there is a lot of penetration of renewable energy resources. You can see there is a load forecasting, which is being now very heavily used using variety of the machine learning technique. Then we have mainly the LSTM RNN because it's a time series data. So we have this load forecasting, and then again they can be differentiated into short-term load forecasting and long-term load forecasting. They can be used at various ways. For example, the load forecasting can not only be used to control our generation process, but also they can be used for effective demand response kind of application. Okay, so these are the ML applications in the power system. If you talk about specifically the unsupervised ML applications in the power system, then they find the application in the planning and management of low voltage networks for clustering. For example, if there is a low voltage network, then you just have to identify that how many clusters are available in our customer sections. Okay, so this can be used for better planning and management. For example, in one particular low voltage network, if you are trying to say there is some unbalanced scenario going on because in some particular phase there is a lot of customers, in other particular phase there are less customers, and then we are facing a lot of unbalancing issues in the entire system and a heavy neutral current is flowing, then in that case what we can do is we can try to cluster them in different phases, and then you can just try to identify that we can move some of the customers from maybe one particular phase to another phase. Similarly for the planning and management. Okay. The second application of unsupervised learning in power system can be the load profiling of the consumers based on their billing data, and which can be used for the tariff determination for different class of the consumers. So you can see that there could be, the consumers can be of different categories. For example, there could be household. Okay. Then there could be shops, like single shops. Then there could be malls. There could be industries also. Okay. So you might see that just by looking at their billing amount, so their billing amount will be pretty much going in this direction, that is increasing order. So you will see the household will have a slightly lesser bill compared to a shop. Of course, when I say shop, it's a decent shop which is having some rooms, air conditions going on. Okay, and then definitely the bill of the mall will be greater than shop, and then the industries will be having higher billing than the malls. And as a generation utility, if you as a distribution also side, if you want to give the incentives to your consumers that see we are having a peak of the load profile at some particular time, so is there a possibility that you can just cut down some of your loads, and then we will be able to do a particular tariff calculation for you. So based on that, you can give an incentive to the customers, but the idea is that which customer should we give our incentives to? So a ballpark idea is that we should give our customers which are there in the malls as well as in the industries, we should give our incentives to them, because if malls are able to cut down their prices, cut down their load requirement at a particular time, then we may see a um, significant improvement in terms of how your generation is being shifted from point A to point B. Okay. Industries you might see, you can see that right now the industries might be having the highest amount of data consumption, electricity consumption. But in terms of industries, you may see that they may not be able to cut down their production. Okay. But malls, you can give them some sort of incentive. For example, you can say that we'll install some solar panels to you, and then in the morning time or in the afternoon time, if you're able to tap down some of the electricity from the solar panels and use it in the evening time, then there is a good possibility. And then the utility itself can take a responsibility of supplying the solar panels to the malls. Okay, but they have to identify the customers. Okay, that's where the unsupervised learning can be of help. Okay, then even there are few interesting problems, that even within the single consumer's residence, by analyzing the patterns of the consumption, we can identify the occupancy period of the consumers, and the theft of the electricity can be found out. Okay. When I say theft of the electricity, what essentially we do is we take the data from the smart meter. Okay. And then there are various kind of attacks which can be there. I'm not going into deep into theft attacks because that's again a cyber security regime. But there could be additive kind of attack. There could be a subtractive kind of attack. Okay. And there could be a combination of this. Okay. So what essentially happens in additive attack, whatever the power consumption you are doing, there would be some sort of attack. Okay. Which is just showing the higher amount of consumption at your meter. Okay. So that is called as additive kind of attack. And then you can look at the single consumer's point of view also. Okay, so if you add the consumer 1, consumer 2, consumer 3, so on, and then the total consumed power at the substation or at the distribution end, then they should add up. But if you are doing this additive thing to few particular consumers, then you can see that this thing will not add up, and then you can come to a conclusion that there is a theft. Okay. Similarly, you can have a subtractive kind of a thing. So you may see that that some of the consumers, for example, if they are using some 100 units of power, then rather than showing the 100 units of power being consumed at the smart meter, they will just show that 80 units of power is being consumed. So that is called a subtractive attack. So the question is where this kind of thing can be of use. So just think about it, where the subtractive attack could be of use. An interesting problem comes when a theft is being done where some of them are becoming additive and some of them are becoming subtractive. Then essentially we'll see that at the substation end there will be no change. Absolutely no change. But at the individual level, there is definitely some change in the smart meter data. So those are the most complex ones to identify. Okay. And then ML is now being used somehow to solve those kind of problems. Very interesting thing, but people are using it. Okay. So we will, if the time permits, I will show you in this presentation, or maybe tomorrow I will show you that what kind of customers can be chosen for a demand response kind of a program. Because as I said, that if you want the consumers to be part of your demand and response, you have to first identify the consumers which are consuming the data beyond certain threshold, and then we rank them, and then based on that ranking we just go to one particular consumer and say that okay, it looks like you are using the electricity at this particular level, and then let us just try to give you some sort of incentives or tariff benefits, so that way we can also shave our peak loading conditions. Okay, so these are the unsupervised ML applications in our system. Now these are the different kind of clustering methods. There is a hierarchical method, there is a partitional method, Bayesian method, there are neural models also. Okay, So what I would do is maybe I will just start with the k-means method, which is the most common one. It's like the most common thing you will see in the clustering one. The k-means method is simply that you just identify first of all the initialize the clusters, okay? And there will be k clusters which are initializing. And then whatever the data points are there, you're just trying to identify that these data points, maybe you will just try to find out the Euclidean distance from those centroids, cluster centroids, and then try to identify whether they are close to one particular centroid or another centroid. And then you will just club them together. Okay, once they are clubbed together, then you will update the centroid position itself. Okay, and then once the centroid position is updated, you will just check that threshold condition is meeting or not. From the previous position that you have and the new position that we have, is it within the threshold or not? If it is not within the threshold, it will just keep on doing this steps. Okay, and then if it meets the threshold condition, then it will stop. Okay, and then you can see that your classification has essentially been done. Okay, so let me just give you a quick example that how this this kind of clustering is done. Okay, so let me just draw two dimensions. So there could be anything which you can write here in terms of dimension. This is dimension 1 and this is dimension 2. Okay, and then let's say there are three different points. One is here, another is here, then there is one here, and one here. And then you can even try to give them some coordinate values if you want. So I'm not showing it here, but you can definitely do that. And then let's just say that we are starting with 2 points like this as the centroids. Okay, so what you will do then is that you'll first try to identify that where they are belonging. So you may at first iteration, you may be able to identify that these two are lying close to each other, so they will belong to, let's say, one particular cluster. Okay, and these may belong to a second cluster like this. So you may have this cluster. Okay, and then you will try to update their positions. Okay, once you update their positions, you will see that the new updated value for the centroids may look something like this. So you will again have the same points like this, but now your centroid positions may slightly change. So you will have one centroid which may still be here after calculation, and then the second centroid may slightly shift and come somewhere here. Okay, and then you will again try to update it, and you will see that okay, there is a group which is coming like this, and then there could be a group which is coming like this. Okay, and then you will again update the centroid position, and then eventually you will see that your centroids will look something like this. Okay, so your centroid positions may look something like this. So one is here and another one is here. Now after that, if you will do a lot of if you will just try to repeat these steps. Okay, so this is one centroid, and then this is another clustering which is happening. Okay, after that you will see that if you again try to update the centroid positions, there will be a very marginal kind of a change in their positions, and then essentially you can say that you are coming to this particular step, that from the location perspective, if you are subtracting their newly calculated location to the previously calculated location, then their distance is coming less than the threshold value, then essentially you can say that you have reached to a particular clustering process, and then you can terminate the process. So that's exactly how the k-means clustering work. And then we have something which is called as a hierarchical clustering. Okay, the hierarchical clustering is essentially it is kind of an agglomerative approach, and there could be a divisive approach. So agglomerative approach is essentially a bottom-up approach, and each object is a cluster initially. Then, so to start with, what you will assume is that each object is a cluster, okay, and then as you go from one step to another step, then you try to merge two clusters together, and then try to come up with a new dendrogram. Okay, and then you try to cut the dendrogram at a desired level. Okay, so there are a lot of words here, so I think it is better to show you what it is. Okay, and the divisive approach, you will see it's exactly the opposite. So this is a bottom-up approach, this one, and this is a top-down approach. So initially in the top-down approach, you will assume that all the objects are belonging to one cluster, and then you will just keep on breaking it down. Okay, so this is an example of hierarchical clustering. This is the example. So I have taken 9 points here. So initially with the clustering, what you can assume is that each point is a cluster itself. Then you join two of them, or merge two of them to find another cluster, and then you take this cluster and then take another point and then try to come up with this cluster, and similarly with the rest of the other points. Okay. So you will see that in the hierarchical clustering, the number of clusters formed are actually decided where the dendrogram is being cut. So for example, if I want to cut this entire thing at this particular point, okay, this particular point, then how many clusters you have? You have two clusters. You have one of this cluster, and then this entire cluster is there. So you have two clusters. Okay, so this is what it is called as cutting the dendrogram.
Professor? Professor, we can't hear you. Professor, can you please check your audio device?
There must be a technical issue on professor's side. Participants
Professor,
are
your audio
requested
has been
to
interrupted.
participants are requested to stay calm and stay in the meeting. We are trying to connect to professor.
I think sir lost his connection. Participants, please be there in the session. Okay.
Are you able to hear me?
So your voice is not clear.
Yeah, there is some technical. I think this Wi-Fi.
Okay, sir, we will wait, sir.
Yeah.
Hello, sir, it's not audible. I think some connection with your issue with your connection.
Is it okay now?
Oh, it's okay now, sir. Okay, sir, we can continue.
So what I'm seeing is anyway around 10:20. So what I can do is I can take some questions. So you can type your questions over chat and I can try to answer them.
Okay, sir. Then tomorrow we can continue with the remaining sessions.
Sure, sure.
Okay, sir.
If you have any questions, just type them. If not, then I will sign out.
Okay. No, sir, you can continue till 10:30, no issues.
Okay.
Okay. So any queries, participants or audience, any queries? You can type it there. Sir, there is a
So
query.
there is a query. Let me just see if I can. So what I will do, I will stop sharing this.
Okay, sir.
Professor, can I read out the query for you?
No, that's okay. I can read them. That's okay.
Okay.
Is it a good practice to digitize? Labels. There was some query. Is there any procedure to have cutoff learning dendrogram? That depends on your Abhirami. That depends on your application. So how many clusters you want to have, depending on that, you can cut the dendrogram. That depends on your application. For example, in the power system, if you just want to cut the dendrogram at 2 points, whether it's a symmetrical or unsymmetrical, you can just have 2 clusters. But if you want to go further, that in the unsymmetrical, you should even tell me that it was a single line to ground fault, double line to ground, that we can even go deeper in the dendrograms and then try to cut it at that point. Okay, there is another question which says, sir, is it a good practice to digitize data points and give corresponding label to each? Yes, that's how exactly it is done. So what you essentially do is that whatever your sinusoidal waveforms are there, you take a particular time step, and then in that particular time step in that window, you take your data and then you write down all your data like VAV, VVC, IA, IBIC, and then you give the label that if your VAV, VVC, IA, IBIC, these values are there, then your label can be, if you're talking about fault classification, then it's a single line to ground fault, or it's a normal condition. Okay, and then that way you can try to come up with a data set which can be used to train your system. Anything else? Any other question?
Participants, if you have any questions, you can write in the chat box.
So tomorrow what I will show you a case study on this clustering, and then I will also show you some fault classification this case studies which are done by my students. So I will show you those things tomorrow. So if there are no more questions, then should I sign out?
Okay, sir. Thank you, sir. So tomorrow we'll meet you.
Can you just remind me again? Tomorrow I think it is 10 o'clock, right?
Okay, sir. So I will mail you. Actually, I will share the link
Yeah,
as well as
you
I
share it with me one more time.
Okay. So anyway, before the class, like today, we will contact you first.
Certainly.
Okay, sir. Thank you. Thank you so much.
Okay.
So just a minute, sir.
Yes.
Professor, sorry to interrupt you. There is one question which has been sent to the question answer block. Can I read it out for you? Is that okay?
Sure.
Application of reinforcement learning in power systems. That's the question.
I think I will answer. I will save that question to tomorrow. I will show you some applications there. Okay.
Yes. Yes.
Yeah, I'll show you the application tomorrow in that particular part.
Yes. Thank you, Professor.
Okay. Okay. Thank you.
Thank you, sir. On behalf of Power and Energy Group, NIT Calicut, I would like to express my sincere gratitude to Professor Prashant Agnihotri for having a great session with us. Thank you so much, sir, for spending your valuable time and effort for the session. Thank you, sir.
Thank you.
Thank you, sir.
Okay. Thank you.
Participants, the polling is open for the first session. You can give in your attendance.